Hello team, I'm recording a practice sheet and you have the blank on the canvas, and every question pause the video and first try on your own. Take a piece of paper or on your screen, draw them and practice. I would say practice, practice, practice. Okay, all right. You can do it 3 hours. I would say take half an hour, another half an hour, each day 1 hour, something like that. Okay, all right. So let's look at this one. Name the reaction and draw products, right? So I have to name the reaction. So what I see is H2, right? And then there is a catalyst here. Let me get rid of one thing. So it's platinum. Platinum is a typical catalyst, and there's hydrogen. So then this reaction should be hydrogenation, or it's a reduction, hydrogenation, right? And it's a reduction too. Adding hydrogen is a reduction. You already learned that one. Now, so I'm going to write this way first. Look at this one here. So I have a pi bond. Pi bond is an easy one to break in the middle, but you're going to see the other carbon skeleton. Do not touch that, right? So now hydrogen, I can write one covalent bond, and H2 gas looks like that. Now what I do, so let me see if I can grab another pen. Yeah, red. If I can break this covalent bond and this pi bond, I can bring this hydrogen here and this hydrogen there. Okay, that's the plan. So let me copy the skeleton. So the skeleton looks like that, right? Okay, now there's another one here, right? That's the skeleton. Now I added hydrogens, one here and one here. But makes sense though. You do have a CH3 here, you do have a CH2 here, you do have 3 carbon bonds here, carbon to carbon, then 1 hydrogen, so it's only a carbon now here, right? Because 4 bonds are satisfied. For this carbon, I need to have another 2 hydrogens, right? And for this carbon, I need to have 3 hydrogens. So that understanding is important. Okay. Now, if you need to write, I would say this, your reactant, and also name the reaction. I said you can also name the product also. You can try to name that one. Okay. I mean the IUPAC naming, right? And then here, this one, your reactant, if you want to see it this way, you could think this is a CH3 at the beginning, then you have a CH2, then you have a C, right? And a double bond, and then a CH3, right? You can also draw this one. That's a double bond CH2. That's another way if this is convenient for you. Okay, all right, so that's that. Now let's follow the similar pattern for the next one, right? And see, I'm following kind of a similar pattern. Okay, water molecule, and so typically like the platinum, if you have this way on the arrow, these are reaction conditions mostly, right? And then this one would be a catalytic acidic catalysis, right? Okay, catalytic acid or proton. That's what you have here. And then you have water, right? So the water is actually can be written as H is bonded to an OH group, right? That's another way of drawing water molecule. Now, if I want to make it easier, I'm just gonna draw the pi bond can be broken in the middle, and then water can be broken in the middle, right? In that case, what I do, hydrogen, you can plant where the more hydrogens are, and the OH gonna go to where the less hydrogens are typically. Okay, now let me name the reaction, because it says name the reaction and draw the product, right? So name the reaction here. Adding water is actually called hydration, or removing water is called the dehydration. Okay, all right. Now let's draw the skeleton first. So my skeleton, I don't touch the original skeleton, so I'm just gonna yes, I have that one, and then I need another one here, right? So that's what the skeleton looks like. Now I added in green the hydrogen of the water molecule, and the OH went to this place, right? So that's the complete product actually. Now if you want to see how does it look like, so you understand here there is a CH3. Every carbon should satisfy 4 bonds, CH2 and a carbon here, because there's all 4 bonds are taken, and there should be a CH3 here. This carbon here, you have 1 hydrogen and 1 carbon bond, so I need to add 2 hydrogens. Okay, now same way, look at the reactant. If you want to draw it that way, you should be drawing CH3, CH2, that's CH3, that's CH2, then you have a C, then you have a CH3 in the corner. Now this double bond you can just draw up CH2. Okay, all right. Where did they go? Okay, there you go, number 2. Yes, number 2, what is the class and the name of each compound? What's the class is, remember I talked about hydrocarbons, right? Hydrocarbons. And then we make alcohols, talk about alcohols. Then we talk about aldehydes and ketones. The general class is carbonyls, right? And that's what basically we talked about so far, right? And if you remember, I said CH4 is the most reduced and CO2 is the most oxidized. You can also see there is oxygen, right? So that means the oxidation goes this direction. Oxidation, right? Okay, and then the reverse is reduction. Okay, all right. So now let's what's the class of these compounds then? So let me write those. So this is a hydrocarbon, right? Hydrocarbon, you have to write complete name though, right? HC, hydrocarbon. Okay, and then this ring is the aromatic ring or benzene ring, right? Benzene ring. So that's what you have here. Now when the benzene ring has an hydroxyl group, and that is called phenol or phenols, right? And then the next one here is a cyclohexane, right? There's 1, 2, 3, 4, 5, 6. So it's cyclohexane. It's an alcohol, right? So this is an alcohol, right? Now let's write the names, right? So the first one is benzene ring, right? And there is a substituent of 2 carbons, so it's called the ethyl, right? So the ethyl is sitting just on the ring, so there's nothing other significant, so I should say 1 ethyl, right? So instead of saying 1 ethyl, we should say ethylbenzene, because we don't say benzene. Okay, there is an E here, E-N-E. Okay, so that's ethylbenzene, and then the phenol name is actually phenol, so we don't have to worry about that. Remember, this is an important one, right? So, okay, so there are a lot of phenolic compounds we're going to deal with. And then the alcohol, this alcohol, first name, let me name this part here. It's an hydrocarbon, but it's a hexane, but it's cyclic, so therefore I should call cyclohexane, and I say cyclohexane because E will be cut, hexane, and then I should say all for that one, and it's 1. I don't have to say 1 all, I can say cyclohexanol, right? If you kids want, separate the names and learn it first. Cyclohexane and all, cyclohexane all. Okay, Now name the given alcohol. In this case, what I do, first alcohol, identify the hydroxyl group. It's not a hydroxide. Hydroxide is OH minus. That is normally sitting with something like K plus, right? This is not the one we are talking about. So hydroxyl group is the functional group. So it gets the name. So our name should end up with ol, right? Because it's alcohol. Right? And then I'm just going to work that way and see whether you can understand me. Now, so we need to choose the longest chain. The longest chain is that one. And then I should give the least number for the priority group. So let me put the numbering. So I should be numbering 1, 2, 3, and 4, right? Okay, so that's the 4, it's a butane, and then the 2 is on the OH is at the second carbon, so 2-ol. So I should say 2-ol, and then how many carbons? Butane, right? Butane. E will be cut, right? And then you have another one here, 1-methyl hanging. So this methyl is actually in the third position, 3-methyl. So I should say 3-big M, because beginning of the name, methyl, right? This one also, if you need, cut them into pieces. Substituent is, this is the sub, right? Substituent is 3-methyl. And then the main chain is butane, and then the functional group is second position at ol, right? You see how we break down. Take your time, okay? And let's do this question. And this is also an alcohol, so that's the OH, so that gets the name. I'm going to start with ol, and then I'm going to choose the longest carbon chain, so that looks like that one, and I can put the numbering 1, 2, 3, 4, 5. It's the way you're going to get it. And because you want to give the least number for the functional group, so therefore I don't need to say 1-ol, right? Because it's 1, but it's pentane, so I should write pentane. So I'm going to write pentane, and E will be cut, and then it's pentanol, right? And it's one term though, right? Pentanol. Okay. Now, so here a little bit of a tricky part. You see, this is an I. So anytime if you have chlorine, bromine, fluorine, chlorine, bromine, iodine, these are halo compounds. The halo compounds don't get the priority. They are not a functional group, right? And so therefore I should be at the 4th. I should write that one 4-iodo. Okay, because it's iodine, so we say iodo or bromo or chloro, something like that. So okay, the name is then 4-iodo pentanol. It's one term though, but you can break it down for you to learn. Substituent 4-iodo, carbon chain pentane, and the functional group 1-ol, but you say ol. Okay. Let's name this compound. Just look at it, and that's actually phenol. Let me make it a little bit complicated. Okay, so let's say I have a group here, bromo, right? Then I should number it, and it's a phenol. I should say it's phenol for sure, and then I should number it 1, 2, 3, 4. Right, that's all I need for now, and it's a phenol and the 4-bromo, 4-bromo. Right, okay, if you need, break it into the substituent and the functional group, right? And do you understand one more thing here? So there are hydrogens here. There is one hydrogen here, because you see, count the bonds each center. 4 bonds, that's the goal. Okay, let's go to this one here. Classify given alcohols for primary, secondary, and tertiary. right? So how do I recognize? There's two ways to recognize. I'm going to do both of them. See which one helps you, okay? Now, first thing, here is a carbon, and this carbon needs 4 bonds. Anything hidden is a hydrogen, so I would say there is a hydrogen here, right? And then this carbon here, all 4 bonds are satisfied. There's no hydrogen. In this carbon here, there's 2 bonds and you need 2 hydrogens. I'm going to stick 2 hydrogens, right? And this carbon here, you have 3 bonds already, so I need 1 hydrogen, okay? Okay. Now, so those are the hydrogens, right? Based on the hydrogen, I'm going to say when you have no hydrogens, it's a tertiary. That carbon is tertiary. So the alcohol is sticking into that one. So therefore, it's tertiary. And then when you have 2 hydrogens, that's primary. When there's 1 hydrogen, that's called secondary. So that's one way to see. I think it's an easy way. In that case, this would be a secondary because there's 1 hydrogen, right? Okay, that's one way. Now I'm going to use my red pen and show you another way. What's that one? Is recognize any group. Any group means anything like R. It could be CH3, it could be C2H5, right? It could be ethyl, methyl, propyl, butyl. You can also say ethyl. It could be butyl. It could be propyl, something like that, right? So therefore, generally we call R groups. You see, without going to CH3, I can say 1 R and another R. When you have 2 R, it's secondary, right? 1 R, another R, another R, then it's tertiary, right? Here is only 1 R because 2 hydrogens taking the other spot, so it's primary. There's 1 R here and there's 1 R here, so therefore it's secondary.